Let's start the next session. In this session, we are going to see the recursion. So, the recursion basically the program which calls itself, the function which calls itself until the how long it calls infinitely, but we have to provide the condition. So until that, the function which calls itself, we call it as a recursion. So here we can see an example definition, try recursion, and we're passing it out. But here, before that, let's okay, it prints recursion example results, and we're calling the function with the argument 6. So k has a value 6. If k is greater than 0, definitely it is greater than 0, it enters the loop. Result is equal to k plus, it calls the function again by reducing of its one value. Okay, so that way again it calls itself and again until and then print the result. When it prints the result, only when the condition false, condition goes false. So k minus 1, again it calls. So the condition is true, 5. So 5 plus the value, again it calls like that. So when it becomes 0, so yeah, 0 which is not equal to 0, then it assigns the result is equal to 0 and it returns the result. So that way the recursion works, and there are few programs which we are going to see here. So let's see one by one. So some of the programs we'll see in this session, and the first program is to find whether the given is number is even or recursive. So here the solution for it is we have to take accept a number from the user, and we have to store it in a variable, and we have to pass that number as an argument, and argument. We have to pass a number of an argument to a recursive function. We have to define a condition as a number which is less than 2, and otherwise we have to call the function recursively with the number -2. So then we have to return the result. So this is how the function works. So let's create a program. So definitely for that, okay, let me define the function. Define, check, I'm passing the variable n. If n is less than 2, so what it has to do, it has to return n %2, which is equal to 0, and return, it has to call recursion, right? So it has to call itself. Check n -2. So now accept a value from the user, n int input, enter the number, and if check n is equal to true, because after returning the value, so it has to print, right, whether the provided number is even or not. Print the number is even, so even, else print else. So okay, done. Okay, invalid syntax. See, again I have not provided a colon here. Invalid syntax again. Yeah. Okay. Who's not defined? Okay. Oh, sorry. It has taken it as a normal string. So we have to give it as keyword. Keyword is true. And what is or? Yeah, this is one of the program where with the help of recursion we have found whether the given number is even or odd. Let's see one more program, that is to find the Fibonacci series using recursion. So to solve it, we have to take a number. So pass that number as an argument to a recursive function named Fibonacci, and we have to define a condition, that is the number to be less than or equal to 1. Otherwise, call the function recursively with an argument of the number minus 1 added to the function called recursively with the argument as the number minus 2. Use the follow to and print it. So let's do it. So I'll use a Fibonacci, the function name as Fibonacci. So here is a condition: if n is less than or equal to 1, it has to return n. Return n. Else what it has to return? Else I have to write a condition else here. Else, okay. What it has to return is, it has to return Fibonacci. Fibonacci n minus 1 and n minus 2. Basically, we know what is Fibonacci series. It starts from 0 and 1, and later it's addition of the previous number. So 0, 1, 1, that is 0, 1, that is common, and later it's addition of the previous number. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 3 plus 2 is 5, 5 plus 3 is 8. So this is how it continues. So for that we have to define range. We have to define the range. If we don't define the range, then it's false. So here we are going to print. So print, okay. So it's number first. Enter the number. I don't know what this. Enter the number. Okay, enter the number 10. Okay, now I have to call it for I in range of n. And right. I have to put it in parentheses. So it exists. So see, as we can see, first one is 0 and 1. So the next is the third number is addition of the previous two values. So that is 1. So that will 0 plus 1, that is 1. Then 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5. So this is how the series goes in the Fibonacci. So let's take 10. So you can see. So 5 till 5 we have seen. 5 plus 3, 8. Okay, 13 plus 8, 21. 21 plus 30, 35. So this is nothing but a Fibonacci series. And the program was to do with the help of recursion by making the function to call itself. So let's find the sum of elements in a list recursively. Sum of elements in the list recursively. So what we have to do is we have to define a function which takes an array and the size of the array as arguments. Then declare the empty list and initialize it to empty list. Instead of for loop to accept values for the list, take a number of elements in the list and store it in a variable. Accept the values into the list using another for loop and insert into that list. Pass the list and size of the list as arguments to the recursive function. If the size of the list is 0, return 0. Otherwise, it has to return the sum of the last element of the list along with the recursive function. So finally, it will store the final sum and it will print it. So let's do it. So let's move this code. Def sum of so let me take this I, and as I told, we're passing array as well as size and argument to it. Then if size is 0, if size is 0, what it has to do? It has to return 0 because nothing is there to add, right? Okay, then else but also we have to define what it has to do. It has to return array size minus 1, return array size minus 1 plus sum of array. It has to call that function like recursion. Yeah, comma and the size minus 1. So that's all for that function. We have to accept the values from the user and input into the number of elements. Elements to your list now with the help of okay. Now let me declare an empty list. And we have to accept a value from the user for that list. I in range that is okay, 0, n. element is equal to this we want anything else. It's better to convert it to integer input, enter the element dot append element. Okay, then just to print, right? Print the list is a in sum of the list. Sum of the list is before that what I do is I'll take a variable b and I'll assign that and I'll call that function with by passing size and array and let's print finally. Yeah, hope it's done. Enter the ns file. Okay, it's getting error. Why? What's the error? Str object cannot be interpreted as an integer. Okay, let me this. We have to convert it into integer. Yeah, see 321432 and the total is 15. So the program was to add uh, the number of elements in the list or to provide some of the elements in the list. So what we had done is we usually basically user enters the number of elements in the list and we store it in a variable and user enters all the values to that list and the append function obtains an each element and from the user and it adds to the list as many times as the number of elements taken at the beginning. The list and the size of the list are passed like an argument to the recursive function. If the size of the function reduces to 0, 0 is returned. Otherwise, the sum of the last element of the list along with the recursive function call is returned. The returned values are stored in a list and some of the elements in the list will be printed. So let me run it once again. Okay, 4. Okay. So you can see 34, 90, 123, 890. So the sum is 1137. So this is one of the program. So the next program in using recursion, that is the Python program to find the power of number using recursion. So power of a number. So we accept a number and power and we provide output. So basically take the base and exponential value from the user, pass the number as an argument to the recursive function to find the power of the number, then keep the base condition. That is if the exponential power is equal to 1, we have to return the base number, right? 5 to the power of 1 is 5, 2 to the power of 1 is 2, right? So it has to return the base number. If the exponential power is not equal to 1, the base number multiplied with the power of function. So it will be called recursively with the argument as the base and power minus 1. So finally the result will be printed. So let's start doing it. Why we are doing all these programs? Because just to get to know how this recursive function works. So for that sake, we are using it. I mean, we are using number of programs on recursion. So what will be passed? Definitely the base value and the exponential. So what if ex- exponential, if it is equal to 1, what I said, it has to return the base. Why? Why? Because anything to the power of 1 is itself. I mean the base value. That is, if exponential, if it is not equal to 1, return what it has to return. So here the the recursion comes into picture. Base star power result. Base comma exponential minus 1, because it has to reduce after multiplying it. So that's all for the definition. So let's accept the values from the user. Base is equal to 8. Let me convert it into it. Rather getting the error and changing it. Enter the base, then exponential. So print input, enter the exponential. Enter the exponential. So print what? The result. Along with that, we are calling that function result. So what we are doing is we are calling that for function with the arguments, that is base comma exponential. Hope it's clear. So we are accepting the values from the user. The accepted values will be like base and exponential. And here we are calling the function that is power exponential. Power, the arguments as base as well as exponential. So those two values will be passed here. If the expression is equal to 1, definitely it will print only the base. I mean, it will return the base and that will get printed. If it is not equal to 1, so the function will be called recursively by reducing exponential each time by 1. And the final result will be printed here. Okay. Let's run the program. So base I'll take 5. Exponential let me take 3. So 1.5. Yeah. Answer is correct. So let's run the program one more time. So let's take a huge value, 120 squares. Oh, we are 2,400. Oh, it's huge. Sorry. Yeah, but it's getting printed, whatever the value it is. Good. Okay. We're done with finding this also. Okay, let's see the last program for this week. One string function. Oh, so one string program is in recursion. So what is that? It is to find, or it is to reverse a string. Whatever the string is given, it will be reversing it and printing it. So for that, we take a string from the user, pass the string as an argument to a recursive function to the reverse of to reverse the string. And in the function, we provide a base condition like if the length of the string is equal to 0, the string will be returned. Otherwise, recursively it calls a function to slice the part of the string except the first character and concatenate the first character to the end of the slice string. So this is how we can reverse it and we can print it. So this is the last program for this video. So here what I'll do is, okay, reverse reverse. So what is that argument? Definitely the string. If okay, length of the string if uh, is equal to 0, return string, else return reverse string slicing plus string 0. Okay, now we have to accept a value, right? String, the input should be of type string, so input, enter string, enter the string which has to be reversed, and calling the function. Along with that, what I'm doing is I'm printing it. Print reverse. Okay. Reverse, and I'm passing the argument as a. Okay, here I want reverse. Hope it's fine now. Yeah, what's the problem? String is not defined. Okay. Okay. You're not supposed to take this. This is still. Okay, interesting. Oh, oh God. It has not many errors. So the first, okay, reverse, okay. Okay, let's see. Definition plus string. If length of the string is equal to 0, return string. Okay, whatever is there, it will be returned. If nothing is there, then what is there to print? It will return and that will be printed. Else, return reverse string string. Okay, slicing, that is string 1 plus string 0. Okay, I have given extra parentheses here. Oh, it has to be this. And enter the string. Yeah, you can see the reversed string. Let's take some. Let me enter the sentence. Right. Entire sentence has been reversed. So those are the examples we have seen for recursion. Let's see further videos how we can add some more programs using function, especially using function. There are some more topics to cover in this module.